Welcome to the learning module of Nirmala College for Women. I am Dr.C.Subha, Assistant Professor, Department of Chemistry, Nirmala College for Women. In this module, let us see about the introduction of group theory. This module talks about the introduction, objectives, and the new terms used in the group theory. Group theory is a mathematical entity by which aspects of a molecule's symmetry can be determined. That is, it is a mathematical entity used to study the symmetry of molecules to reveal the properties of molecules. In other words, we can say group theory can also be considered as the collection of symmetries of some molecules preserving same structure which forms a group. The significance or objectives of group theory are: the molecules can be categorized, properties of molecules can be predicted, we can assign the point groups of the molecules, vibrational transitions can be determined, and EMR interactions can also be predicted. So what are the new terms used in group theory? The new terms are symmetry elements, symmetry operations, and groups. Now we'll look into these new terms one by one. Symmetry elements is nothing but the geometrical elements like line, plane, or a point with respect to which one or more symmetric operations are carried out. Next, the term is symmetry operations. It is nothing but a molecule or object is said to possess a particular operation if that operation, when applied on a molecule, leaves the molecule unchanged. The third term is groups. Group is a collection of elements having certain properties in common which enable a wide variety of algebraic manipulations to be carried out on the collection. Now we'll discuss about the symmetry elements and symmetry operations, their definition, examples, and their types. Definition for symmetry elements is: it is a line, a plane, or a point in or through an object about which a rotation or reflection leaves the object in an orientation indistinguishable from the original. That is, a lane or a plane or a point is considered as a symmetry element. Examples are line of symmetry, that is, in the cube, the dotted lines represent the lines through which a rotation can be done or a reflection can be done so that we are getting an equivalent configuration to the original. Next example is the point of symmetry. Point is nothing but a dot through which an operation can be carried out to get the equivalent configuration. Plane of symmetry, horizontal plane or a vertical plane can be used to get an equivalent configuration of the given molecule. Next is symmetry operation. The definition is: it is the movement of a body, that is a molecule, such that after the movement the molecule appears the same as before. Example: rotation operation. In the given example, we can see the deuterium substituted water molecule is rotated by 180 degree to get an equivalent configuration. That is, the configuration is indistinguishable from the original one. This is another example where a molecule can be rotated through an axis or through any angle to get an indistinguishable configuration from the original one. Next we'll see about the symmetry operation. The types of symmetry operation. 5 types of symmetry operations are there. First one is identity operation. Second one is rotation operation. Third one is reflection operation. Fourth one is inversion operation. Fifth one is improper rotation operation. The first diagram represents the molecule, the inversion operation carried out on a molecule. The light blue color lobes represent the atoms, and the center point is used to invert the molecule so that we can get an equivalent configuration. The second diagram shows the examples of rotation operation and reflection operation. Rotation operation is done through the axis of symmetry or the line of symmetry. Reflection operation is done through the mirror plane, which is an example of symmetry element. Horizontal plane or a vertical plane is used for the reflection operation. The first molecule is an example for identity operation. Identity operation is nothing but doing nothing on the molecule. Hence, almost all the molecules will have identity operation. Next diagram represents the improper rotation operation. Improper rotation is nothing but rotation followed by reflection to get the equivalent configuration. This table represents the comparison or the summary of what we have seen in this module. Symmetry elements, 5 different symmetry elements are given, and according to the element, what operation we can do is given in the second column. First element is identity operation. It is represented by the letter E. So what operation we are doing? We are doing nothing for identity element. Second element is proper rotation axis or axis of symmetry. It is represented by capital C to the subscript small n, that is Cn. Rotation about the axis through some angle is done for proper rotation axis of symmetry. The third symmetry element is mirror plane, or we can say it is a plane of symmetry, and it is represented by sigma. So reflection about the plane is done for the plane of symmetry. Next is inversion center or center of symmetry. It is represented by small I. So inversion through a point can be done to get the equivalent configuration, or we can say it is a reflection about a point. The last one is it is improper rotation axis or rotation reflection axis. It is represented by capital S to the subscript small n, that is Sn, rotation about an axis through some angle followed by a reflection in a plane which is perpendicular to the rotation axis. Thank you for watching this video.